Welcome back to Mr. Vaughn's classroom, where math is made easy. Today we're looking at Unit 7, Quadratic Equations, Lesson 5, How Many Solutions? The learning goal today is to use graphs to investigate quadratic equations that have two solutions, one solution, or no solutions. We have two learning targets today. At the end of the lesson, we'll come back and review them to ensure you've learned everything that you need to. Learning target number 1 says that you can explain why dividing by a variable to solve a quadratic equation is not a good strategy. Learning target number 2 says you know that quadratic equations can have no solutions and can explain why there are none. We have one glossary term for this lesson: zero product property. The zero product property says that if the product of two numbers is 0, then one of the numbers must be 0. And we actually talked about this back in Unit 6, that if I'm multiplying two numbers together and my answer is 0, then the only possible way that that could happen is if one of the numbers that I'm multiplying is 0 itself. Now we can begin the practice problems for Unit 7, Lesson 5. Practice problem number 1. Rewrite each equation so that the expression on one side could be graphed and the x-intercepts of the graph would show the solutions to the equation. So if you're having a hard time understanding what they mean, remember that x-intercepts have a y that equals 0. And if a function equals y, then what we want to do is we want to rewrite the equation to equal 0. So we want to move everything they've given us to one side and have 0 on the other side. So for number 1, they give us 3x squared equals 81. So if we subtract 81 from both sides, then this becomes 3x squared minus 81 equals 0. This is all they are really asking us to do. And the reason that we're doing this is in this unit, we are going to look at methods of solving, such as factoring, or completing the square, or the quadratic formula. And the first step we're going to want to get used to doing is this right here, where we move everything that we have to one side so that it is set equal to 0, and then we will begin the process of solving the equations. So number 2, we have x minus 1 times x plus 1 minus 9 equals 5x. So what we can do is we can go ahead and multiply these parentheses together. So I'm going to have x times x is x squared. X times 1 is x. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. Then I can bring down this minus 9 equals 5x. I'm going to combine the x terms, and I'm going to combine the constants. So I have x squared. X minus x is 0, so that goes away. Negative 1 minus 9 is negative 10. And now I'm going to subtract 5x from both sides. So I have x squared minus 5x minus 10 equals 0. So now we have it rewritten where this left side could be graphed, and the x-intercepts of our graph would give us the solutions. Number 3. X squared minus 9x plus 10 equals 32. We're going to subtract 32 from both sides, and we have x squared minus 9x. 10 minus 32 is negative 22, and it equals 0. Now the left side can be graphed, and the x-intercepts would show the solutions. So now we would be able to begin our process of solving this. And finally, number 4, we have 6x times x minus 8 equals 29. Let's go ahead and distribute the 6x. So 6x times x is 6x squared. 6x times negative 8 is negative 48x. And now we're going to subtract 29 from both sides, and we get 6x squared minus 48x minus 29 equals 0. Now the left side could be graphed, and the x-intercepts would show us the solutions to the equation. So this is what we want to get used to doing first in this unit, because as we move forward and we start to learn ways to solve these and what those solutions represent, this is going to be our first step. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2. Here are equations that define quadratic functions f, g, and h. Sketch a graph by hand or using technology that represents each equation. So if we look at function f, we see that this is in standard form. And I know that I can use standard form to find my y-intercept. So my c term plus 4 tells me that my y-intercept is at positive 4. So I go up 1, 2, 3, 4, and I plot my y-intercept. Then I see that my ax squared term is positive, so that tells me it opens up from there. So I can simply draw a parabola that goes up from my y-intercept, which is also my vertex, at 0, 4. Next, we have g of x. I can see that this one is in factored form. And I know that with factored form, I can use this to find my x-intercepts. I set x equal to 0, and that means I have an x-intercept at the origin. Then I set x plus 3 equal to 0, and x must be negative 3 because negative 3 plus 3 equals 0. So I go over to negative 3 and I plot another x-intercept. I can see that if I multiplied x times x, I would have a positive x squared. So I know that this graph is opening upward. I know that my vertex is exactly halfway between my x-intercepts, so I know that it is somewhere at x equals negative 1.5. That means I can substitute negative 1.5 in for x, and I would have negative 1.5 plus 3 equals positive 1.5, and that would be positive 1.5 times negative 1.5. I can put that into a calculator. 1.5 negative times 1.5, and that would be negative 2.25. So I'm going to go over to negative 1.5, down to negative 2.25. I'm going to put my vertex, and then I draw my parabola opening up from there. Next, I have function h. This can be said to be in both vertex form and factored form. And this happens when my vertex is my x-intercept. So if I set x minus 1 equal to 0, then x must be 1. So I can plot my vertex and my only x-intercept right there. If I want my y-intercept, I substitute 0 in for x. 0 minus 1 is negative 1. Negative 1 squared is positive 1. So I can plot my y-intercept and draw my parabola opening up from there. Number 2, determine how many solutions each function set equal to 0 has. Explain how you know. So what you need to know here is that if the function equals 0, the solutions are the x-intercepts. And the reason the solutions are the x-intercepts is because y equals 0 at x-intercepts. So, if we're looking at these, f of x does not have any x-intercepts. This parabola starts up at y equals 4, and it opens up from there. So y is only ever going to have a value of 4 or greater. So f of x equals 0 has no solutions. When we look at g of x, we see that g of x starts below the x-axis and opens upward, crossing the x-axis twice. So that means g of x equals 0 has two solutions. And those solutions are at 0 and at -3. So what we're really saying there is g of x will equal 0 when x is 0 and when x is -3, because y will equal 0 when x is 0 and x is -3. And then finally, h of x actually has its vertex on the x-axis. Therefore, it has one solution. So this one solution is when x equals 1, because y will equal 0 when x equals 1. So as we go throughout the rest of this unit, this is the important thing to understand. There are only 3 possibilities for solutions. Either there are no solutions because the parabola is either entirely above the x-axis and opening up, or entirely below the x-axis and opening down. Or there could be one solution because its vertex is on the x-axis, So the vertex and the x-intercept are the same thing, and that is the one solution, because then it either opens up and never crosses the x-axis again, or it opens down and never crosses the x-axis again. Or your third solution, it has two possible solutions because the parabola either starts below the x-axis, opens up, and crosses it twice, or because the vertex is above the x-axis, opening down, and again crosses it twice. If you have any questions about any part of this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 3. Mai is solving the equation the quantity x minus 5 squared equals 0. She writes that the solutions are 5 and negative 5. Han looks at her work and disagrees. He says that only x equals 5 is a solution. Who do you agree with? Explain your reasoning. So there are several different ways that you could answer this question. First off, you could simply try substitution and see what works. If I say x is 5, then I have 5 minus 5 squared equals 0. 5 minus 5 is 0, and 0 squared does equal 0. So 5 works. Then I could try substitution and do negative 5 minus 5 squared equals 0. Negative 5 minus 5 is negative 10. And negative 10 squared is 100. So that one does not work. Han is correct. That's one way that you could think about this problem. Another way that you could think about this problem is that x minus 5 squared is x minus 5 times x minus 5 equals 0. So I only have one factor. I just have it twice. So if I set x minus 5 equals to 0, I add 5 to both sides, and I see that my only x-intercept is at x equals 5. Again, Han is correct. And the last way that you could think about this is that x minus 5 squared equals 0. This is both factored form which finds the x-intercepts, and this can also be thought of as vertex form, which is used to find the vertex. This only happens if the x-intercept is the vertex. And if the x-intercept is the vertex, then there can only be one x-intercept and only one solution. So again, Han is correct. All three of these methods of thinking will lead you to the correct answer on this question. So whichever way of thinking about this makes the most sense to you, use that method. If you have any questions, leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 4 is our last practice problem for this lesson. Decide if each equation has 0, 1, or 2 solutions and explain how you know. So looking at number 1, I see that it is in standard form. So I know a couple of things from standard form. First, I know that my C term is my y-intercept. So here, I have a y-intercept at negative 144. And I know that I don't have a bx term, so this is also my vertex. This is my parabola where the vertex was at the origin, and now it has been shifted down 144 units. So vertex below x-axis. Then I know that I have a positive x squared. That tells me this is opening upward. I know that this is going to cross the x-axis twice. So 2 x-intercepts equals 2 solutions. So number 1 is going to have 2 solutions. Number 2. We have almost the same thing. It's in standard form, only this time the y-intercept, which is also the vertex, is up at 144. So this one, the vertex is above the x-axis. And since I still have a positive x squared, this is also opening upward. If I start above the x-axis and then I open upward, it will never cross the x-axis. So there are 0 x-intercepts, which means there are 0 solutions. Number 3. This one is in factored form. I can see that I have 2 different or unique factors. So 2 unique factors. This means I'm going to have 2 x-intercepts. I would set x equal to 0 and know that I have an x-intercept at the origin. I would set x minus 5 equal to 0 and know that I have an x-intercept at 5. So 2x-intercepts means 2 solutions. Number 4. I can see that this is in factored form, and it's also in vertex form. I can also see that I only have one unique factor. And this is because the x-intercept and the vertex are the same. So since I only have one x-intercept, I only have one solution. And finally, number 5, I can see that this is in factored form, I can see that I have 2 unique factors, so I would have 2 x-intercepts, one at -3 because -3 plus 3 equals 0, another at -7 because -7 plus 7 equals 0. So if I have 2 x-intercepts, then I have 2 solutions. So hopefully you have a good understanding that if you set your equations equal to 0, then the solutions to your function are going to be your x-intercepts. And there's only 3 possibilities. You either have no x-intercepts and therefore no solutions. You have one x-intercept, therefore one solution, or you have 2 x-intercepts and therefore 2 solutions. If you have any questions, please leave a comment below and I'll get back to you with any help that I can offer. Before we finish this lesson, let's go back, take a look at the learning targets, and ensure you've learned everything that you needed to from this lesson. Taking another look at our 2 learning targets for this lesson. Number 1 says that you can explain why dividing by a variable to solve a quadratic equation is not a good strategy. We didn't really talk about this in the practice problems, but if you divide by a variable, you actually end up getting rid of one of the solutions. Because as you noticed on a few of our examples, we actually had one of our factors being x itself. So maybe we had x times x plus 3. Well, if I divide by x, then I'm losing that intercept that was at the origin. And so We don't want to divide by a variable. We just simply want to factor that side so that we see both of those x-intercepts. I don't want to divide both sides by x and end up with x plus 3 equals 0, because then I only get one of the x-intercepts, and I think that I only have one solution, when in reality, if I had just simply factored out that x, now I would see both of those factors, and I would know that I had two solutions and not one. So we never want to divide both sides by the variable if 0 is on the other side. We want to factor that variable out and use it as one of the factors so that we see both of our answers. So that's the first learning target. And then learning target number 2 says that you know that quadratic expressions can have no solutions and that you can explain why there are none. And this happens when you don't have any x-intercepts, because if I set my function equal to 0, I'm saying that y is equaling 0, because the value of y and the value of your function are the same thing. So if I say that my function equals 0, therefore my y equals 0, but I never have a point where my graph crosses the x-axis, or at least is on touching the x-axis, then I don't actually ever have a point where y equals 0. Therefore, I never have a point where my function equals 0. So this happens if my entire parabola is above the x-axis, because its vertex starts out above the axis and then it only gets bigger from there. Or it happens when my vertex is below the x-axis and then it opens down, so it only gets smaller from there. And it never hits that x-intercept, or never hits the x-axis, and I never have an x-intercept. So the important thing to understand here is that your solutions are your x-intercepts. So either the whole thing is above or below, you never have an x-intercept, so you don't have any solutions, or your vertex is your only x-intercept, and then you open away from there, and so you only have that one solution, or you start out above the x-axis and open down, and you cross it twice and have two solutions, or you start out below the x-axis and open up and cross that x-axis twice and again have two solutions. So I'm hoping that this helped you out. I'm hoping you understand everything you needed to from this lesson. If you found this video helpful, somewhere on the screen you should see another video that YouTube thinks you will also find helpful. Please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.